All right, the chapter that we're going to begin working with today are rational and irrational numbers. Rational and irrational. Okay, a very general description or definition of a rational number is anything that can be turned into a fraction. Okay, anything that can be turned into a fraction. So all these numbers down here, these are examples of rational numbers because I can take 5, I can make that into a fraction. 5/1, done. 0.5, I can turn that, it's 5/10. 5/10. Turn that into a fraction. Should reduce it. It should reduce down to 1/2. Still the same thing, but it's a rational number because it can be turned into a fraction. Okay, here's another decimal. It's a mixed numeral. It is a 1.5, 1 and 5/10, or 1 and 1/2. Okay, those are, or you can even make it an improper fraction. 3/2. 2 times 1 is 2, plus 1 is 3. 3/2. That's a rational number because I can change this decimal into a fraction. 1/3. How can I change? Oh, wait, it already is a fraction. So that is a rational number. Now this one down here, the 0.3 repeating, okay, we're going to go over how to convert repeating decimals into fractions in a day or so. Okay, right now, just suffice it to say, a repeating decimal can be turned into a fraction. As long as it's repeating, I can change any repeating decimal into a fraction. I'll show you how to do that later. Right now, 0.3 repeating is 1/3. It's 1/3. I'll show you later. Okay, so any repeating, any terminating decimal that can be turned into a fraction is a rational number. Conversely, opposite of that is an irrational number. These are numbers that cannot be turned into a fraction. One that comes to mind right off the bat is pi, because pi is a never repeating, non-terminating, never-ending number. If you remember, it's 3.14, blah, 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 blah. Who cares about the rest? All you need to know is that it's 3.14. But you can't turn this into a fraction because it never ends and it never repeats. Other examples of this are non-perfect square roots of numbers. And we're going to show square roots. Well, I can show you right now. The square root of, let's say, 25, that actually would be over here. The square root of 25 is a perfect square. And the square root of 25 is 5 because 5 times 5 makes 25. So this would be a rational number. So I should erase it from over here on the irrational side. Okay, but if I change this ever so slightly and make it 24, 24 is not a perfect square. It's a pretty ugly square root. Okay, it's somewhere between 4.5 or 4 point something. It's probably something like 4.9, yada yada yada. It's not a perfect square. So anything that's a radical or a square root is an irrational number. Okay, so the difference between rational and irrational. Rational numbers are numbers that can be turned into fractions. Irrational numbers are ones that cannot be turned into fractions, like pi and a never-ending, never-repeating decimal. So if you got something like this, 3.7482, blah, 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 that means it keeps on going, but there's no pattern to it. There's no repeating part of it. That's a non-terminating, non-repeating decimal. Boo, not rational. That's an irrational number. Okay, come back to this video. Help yourself out when you're going over further worksheets with this. We're not quite to the rational, irrational yet, but it's something that'll help you eventually.